Um, I am a technical lead at Cora HQ. I don't know how many people know Cora. Okay. Have you integrated Cora before? All right, cool. That's nice. All right. And I previously worked at Paystack before I moved to Cora. Um, so, like I said, I wanted to quickly address something. There was a question that someone asked because I was in one of the sessions upstairs, and the guy asked about API testing, right? That in their I don't know, in their setup or in a particular microservice you have up to like 1,000 tests, right? And every time you are trying to commit because you've integrated OSCI. How many of us know OSCI? Yes. So OSCI will force it to run certain Git hooks before committing, right? So imagine that you made just one line of change, and you have to, and OSCI has to run all. I mean, pretty much you have to run the 1,000 tests, right? It can be crazy, and we had that issue on my team. I think late last year we had that issue where the service actually grew to a point where we had too many tests, right? And it was taking more time to run. It was taking more time to commit than the actual implementation. Yes. So I just want to say, okay, what did you do? So let me share what we did, just so that it might help somebody, right? So there's a way you can limit the amount of tests that are run, right, or the coverage, right, to just the changes that you made, right? So that's one way, right? I don't want to go into details, but yes, I would. Maybe I'll share. I'm trying to see how I can do that without, because I have my own topic. But yeah, that's a possibility, right? There are packages that actually like help you do that. So you can restrict the even the same thing applies to links changes, right? It's restricted to Ablative. I like. Okay, everybody, let me greet Ablative. He's my colleague. Let me clap for him now. Yes. So you can restrict the changes to just the hooks to just the changes that you made. Now we have AI, so you can actually like do a lot of research on that. Okay. So okay. I really like to control the slide movement, but you're here for me today, Abby. Okay, cool. All right. So like I said, my name is Ibiniyi. I tried to look for a better picture, right? I've been using this picture for like 3 years. It was a birthday photo shoot, right? Usually there's one picture I used to use, and then someone just reached out, and I was like, yeah, you can't be using this picture. And because I don't take a lot of pictures, like I mean, photo shoot, I'm not a like photo shoots kind of person. I don't have pictures, so I just picked one of my birthday pictures, and here you have it. So you can pay for my next photo shoot session if you want me to use a better one. But yeah, my name is Ibiniyi Obikoya. I should not change it. It's fine, Abi. My face did not change. Yes, in fact, that's a really good metric to decide on when to take new pictures. Yes, that's a very, very good metric. If my face does not change, why should I take new pictures? I mean, when so let me just get an idea of how much time I have. I have 20 minutes. Okay, I'll still be fine. Let me make everybody happy. Do you like that? Yes. So I don't like when my sessions are very tense. So when you go for burial and then they do a pamphlet now of all these old people, and they show, oh, daddy with grandchildren, daddy with this. Imagine if daddy did not change, if the face of daddy did not change, and daddy when he was 20 is the same daddy when he was 80 years old. The reason why they share those things, I think, is so that you can see the evolution of daddy's face. So if daddy has not changed, why are we taking new pictures for daddy? You get. So that's food for thought. I have a point, Abby. Food for thought. And just to also share, and I would like to know this. There's a guy at my workplace, and so I never met this guy before. There's a particular picture he used as his profile picture on Slack, and I'm sure some of us can relate. So I had a mental picture of this guy, and then for the first time ever, all of us came together at the office, and I was looking for, where's Ugo? Ugo. Apparently, I'd seen Ugo. I did not know that the guy. It's as if the guy put his picture from when he was in primary 3, and then when I saw the guy, so the picture was like, okay, it's like my younger brother. So I was like, okay, when I see this guy, I will know. Apparently, this guy is like my older brother. By the time I saw him, I was like, oh wow. And that's actually happened for everybody. Everyone was looking for Ugo, and we didn't know who Ugo was, right? So that's just to start on the lighter note. Next slide, please. All right, so I'm here to just share a few things, right, about building resilient microservices, focusing on APIs, to be honest, right? And I'm going to be using a particular use case, right, which is KYC. The reason for that is I think I've spent enough time on KYC that I think I can speak about it. Even though I work at a fintech, I've worked in 3 fintechs now in the last, say, 5 years. I've never been on a team where I actually processed the actual payment. Yes. So when people see me and say, okay, there was a time I did that actually at Paystack. I worked on terminals, but just for a brief moment. So when people hear, oh, Ibiniyi is at Cora, is from Paystack, worked at Global Accelerex, people just think, we want to build a payment solution, come and help us build it. Not that I cannot build it, right? But I have more context around a different part of the system, and that is KYC for me. I've spent enough time around KYC that if I see a system that does not work, I would know, because I've seen it fail, and we've rebuilt, right? So yes, we'll be looking at it from the lens of KYC, which is the foundation of trust and growth, right? And why? Because the idea, this particular session is, I think there's something around when the stakes are high, right? In the topic. So I'm sharing this so you can see that KYC is actually a very critical part of the system, right? KYC is the gate man, pretty much, right? Nothing enters the system without going through the KYC, right? The way you say nobody goes to God without going to Jesus. Yes, KYC is in fintech space, and also in other spaces too, depending on what space you find yourself, right? So it's more than a form, right? It's what prevents fraud and protect the entire system, right? It also determines, like, we use it. It's very important when it comes to our license to operate, right? No, not our own license. I mean the merchants on our systems, right? If we can't get your KYC right, you're not going anywhere, right? And then yes, without KYC, I mean, all of that services are pretty much handicapped, right? I had a call recently with one of the leads of other teams, and they want to integrate with a new provider, but they need certain documents that they need to submit on behalf of the merchants. And guess what? We are the ones that keep those documents. So imagine that we don't have those documents. Is it now that we'll be asking the merchants that we have bring NIN, right? So that's just to show how critical KYC is. Next slide. Yes, and when it comes to KYC, right, these stakes are not theoretical. Real stuff happened, right? I'm sure you must have heard that, oh, a company lost this amount of millions of dollars, right? So we can lose money, right? We can lose trust, right? And honestly, we can lose license. Yes. If you've worked in the fintech, you know that we have regular or periodic audits, and then they will come and say, oh, you have to present some certain data you have about certain merchants, right? They will literally come through your merchant data and ask, oh, this person, do you have this information about this person? So we have to get that KYC part right. Next slide. Yes. Now, when it comes to building anything resilient, right? Assume everything will fail. It's a very, very fair assumption because everything fails. As long as it's not God that built that thing, it will fail. I'm telling you. And trust me, there was a time in my life that I just felt like people that build things that fail, they are not good. It's because they are not good. I'm telling you. If you are good, you can build it. Abi? Don't you think so? Oh yeah, now don't you think so? It depends. If you are good, I used to think if you're actually good, right, it should, like, you should be able to build a perfect system. But I've learned over the years, in very very hard ways, right, that it's literally impossible, right. And the singular reason for that is because you're not God. You can't predict the future. Like, you'll be shocked that merchants will use your APIs and use your system in ways you cannot fathom. Like, we have a dedicated QA system, QA team, and even they fail to think of what the merchants can do with our systems, right? So you have to assume everything will fail, and with that in mind, you don't try to build for perfection, but for recovery, right? Because when you have that mindset that, see, all these things you are doing, because I think I learned not the hard way. When I was at PageStack, my tech lead then, whenever I tried to, maybe I designed something, then he would always ask, what if? What if? Like, can't you just assume that some things will just work? Like, let's just assume that, okay, assuming it did not fail, all of us will be fine. But the truth is, it will fail. Like, you are writing, literally in your code, you are writing, okay, 2 plus 2 is 4. That's just an analogy. And then your tech lead is coming to say that, what if 2 plus 2 is not 4? What do we do? How would the system react? And that's actually how to build a resilient system. Like, asking those questions. What if this happens? What if this happens? Right? Next slide. Yes. So, I just put together 3 patterns, right? I mean, that I've worked with in the past. And definitely, to be fair, we have more than 3. But if we start sharing everything here, I'm not prepared to sleep in this place. I didn't plan to sleep. Here you get. But so I just picked 3, right? And those are the ones I'll be sharing. And number 1 is the circuit breaker pattern. I'm sure a lot of us have even heard of circuit breaker, right? So the circuit breaker, just like the ones we have at home, right, is the concept that we don't want one bad appliance to burn the whole house down, right? So I think there's something I thought I added something there. I wanted to add a caveat that the KYC system I'm talking about is we integrate. It's more like an orchestrator, right? We don't outrightly provide KYC services, right? But we integrate with multiple providers, right? And any of these providers can fail at any point in time. And there are times that there are times that you have this provider that can, let's say, validate BVN, and then this other provider can also validate BVN. But there are times that there's only one provider that can validate that BVN, right? So the question is, so what do we do, right? And that's where this circuit breaker pattern comes in, right? In a case where, say your provider is down, right? And you keep calling that provider, The truth of the matter is that if you call that provider, there's usually a 30-second period, right, that we give in terms of like timeout, right? That's worst case scenario, right? Ideally, it shouldn't be that much, but we don't control these other services. And I hate the things I can't control. I really do. Like, it's just easier when you can control it's within your control, but that's really all what engineering is all about, right? You can't build everything. If you try building everything, you will leave what really matters, and you'll be battling with issues that you should not be battling with. Recently, my younger brother was working on a project, and he was building he was using a monorepo approach where he has multiple services inside the same code base, and he thought that it was very wise that he would orchestrate like everything, write the Docker file to build everything, write the the TS config to build everything and run it once. And I was just, if you don't call me, I will not talk. He just called me one day. I was like, so you have been battling with one problem for like 2 days. I was like, hey, what's the problem? Let's check it out. And I saw what he was trying to do. I asked him why. If you are Yoruba, you know that when they say, Gbero Eleru Sori. Sorry, Gbero Eleru Sori, Ufati Edani. You carry someone else's problem on your head. and you now carry your own as handbag, right? That was what he was trying to do, right? He spent 2 days trying to debug something that we already have a framework, we already have services, we already have platforms that they've perfectly solved this problem. Instead of you to use them and focus on your business logic, right? That's just to reiterate that you cannot build everything, and it means that not everything will be within your control, right? So the idea of the circuit breaker pattern is so that you can stop calling a service that's already down, right? Imagine a scenario where you are calling a service, there's an API, let's say we expose a verify API, and that API calls, I don't want to call any system, say it's Michael that builds that company, right? And we're calling Michael's API, right? But for one reason or the other, that API is down, right? It means our API is down, right? And people will keep calling it. And our system will keep calling Michael's system. And what happens is that we'll keep spending 30 seconds waiting on Michael's system. And then another request comes in, waits 30 seconds. And then another request comes in, wait 30 seconds. Little by little, you are using up the memory of your server, right? And the best way to do is just to fail fast, right? We already know that Michael's server is unreliable at the moment. Sorry, Michael. But we know that it is unreliable at the moment, right? Why are we stressing ourselves? You have someone that has disappointed you. Why are you putting up your expectations again, right? So in that kind of scenario, you open up the circuit breaker trips open, right? I mean, it's clearer in implementation. So I didn't bother to add implementation because you can use ChatGPT to figure that out, right? So the circuit breaker trips open, right? And then every request that comes automatically just assumes that Micro's system is down. But there's a scenario where the circuit breaker is half open, right? And that is where we, based on certain logics, right, we allow certain requests to just go and check it, whether it's backup. And in that case, if it keeps disappointing us, just close it. So depending on how you want to implement it, you can go from closed to half open, right? Because it could be a thing where the service is just up and down intermittently, right? So in that case, you might want to try the half open approach. But again, in my case, I'll just open it. Like, let's not stress ourselves for now, right? So that's the idea of the circuit breaker approach. Next slide. Then number 2 is rate limiter. This one, pretty much straightforward, is to protect our service from too much of a good thing. Yes, the reason why I said too much of a good thing is when someone calls our API, it's good, right? When we expose an endpoint for you, right, and that's one of the things we have at Cora at the moment. We are exposing like identity services, so you can call Cora to validate your BVN and stuff. So imagine that we now expose an endpoint for you, and then maybe one of your developers in their infinite wisdom decides that, okay, they want to be calling, or maybe through a bug. It can be an honest mistake, right? Someone forgot, maybe they are trying to implement a retry logic, and then they want to retry 3 times, and they forgot to increment the for loop, and the thing just kept running. In that case, now it will bring our service down if we don't have something like this, right? So it's a way of ensuring that whoever is calling our endpoints or our APIs conform to a particular behavior, right? Nothing that you do will bring down this our service, right? So even whether it's a mistake or you decide that you want to intentionally now try your luck, right? It's not going to work, right? That's the idea of the rate limiter. Recently, we are implementing a name check endpoint where you can, this thing that we have on YouTube. I think GitHub has it too. When you type the name, username, and then there's an endpoint that just goes to check whether that name exists, right? Yes. So someone was implementing it on my team, and I was just going through the implementation. I was trying to see, okay, what did I miss? I knew there was something I was missing in the review of that code because I had already approved it, and then I was checking it again. I was like, okay, there's something missing in this thing, and I realized that we need to rate limit this endpoint, right? If we don't, and I had to have a conversation with the front end developer. How often is it called from the front end? What logic do you use to call it? So I use that to determine a good frequency that you should be calling that endpoint normally from the front end within 1 minute. And then we use that to set the limit. You get? Because that can easily bring down our old service if we just forget that part. It's a simple endpoint now. It's not as if it's doing any serious harm, right? But try making 1,000 requests in 1 minute, 2,000 requests in 1 minute. It uses up your server space. Before you know it, your payment endpoints are not even going through anymore. Not because of any other thing, no. And you see other teams, everybody's now running around because of your own mistakes. And that's the thing about working in a team. You can cause every other person in the company not to sleep because you made one small mistake, right? So next one. Yes, this one is the fallback pattern. If the primary fails, and you can see is a detour, right? When the road is blocked, you take this shortcut now. Another road actually. It might not be a shortcut, honestly. It might be a longer one because the main one is probably the shortcut because I think we want cheaper services. In a case where, because we pay for all these verifications, right? So we use certain logic to determine what's the best provider to use. Let's say we assume that, okay, is Victor's service that I want to use for BVM registration, sorry, BVM validation, and then it keeps failing, right? Whenever it fails, right, we have retry logic, right? We have the retry logic, but I like to think that retry logic should be around certain kinds of errors. There's certain kind of errors that when you get, don't bother retrying, just move on. Yes, just move on. Don't bother, just move on, right? Try something else. So that's the idea of the fallback pattern. It's just to ensure that the consumer never gets to experience the failure, right? So it ensures that when something fails, it's just an alert. It's not an incident. You get? Because if this is not put in place, when something fails, right? When one of your providers fails, then your merchants or your clients will start seeing error. There's nothing I hate more than when I'm consuming an endpoint and I'm seeing 500 and I'm seeing what is very common, trying to read undefined of something. Why are we doing this? Like, I hate that thing, right? So that's just to ensure that that does not happen to you. Next slide. Yes. And then it's just the last, it's not a pattern, but it's just something you need to do, right? Monitor your resilience radar. I know we've had, I don't mind this one. I have to go and look for one dashboard that looks like it's real. Okay, I don't know whether it's real, so don't wonder. I don't know too. So the idea of monitoring your resilience radar is, like I said, your dashboard is your first responder. There's something I wrote here that I'm trying to get to. Just give me a minute. But because it's important that I say it. Okay, yes. So I said that a resilience strategy without monitoring is just wishful thinking, right? So I mentioned circuit breaker. I mentioned the failover strategy. It's important that you monitor how often, right? Your circuit breaker should have a separate dashboard on its own that you can monitor. The same thing with failover. You should monitor how often you fall back. Not failover. It can be called failover also, but you should measure how often you fall back, like from a particular provider, right? Because it might just be a pointer that there's something wrong. If we made 10 requests to verify a particular document, and 9 of those requests, let's say the first one was good, and then the remaining 9, we kept failing, we kept falling back, is a pointer that there might be something wrong with that particular integration or that particular provider, right? And honestly, you probably wouldn't know unless you set up alerts that there's something wrong with this provider, right? I've been in scenarios where, I just went on and implemented that fallback strategy, right? I just added logs, and you can see the logs on Datadog, but you have to be very proactive to go and look for it, to see it, right? So we had a scenario where a provider, not Accra, a provider was down for almost a week, and I did not know. Why? Because the request was being routed to the other provider. And one day, that other provider will be down, and you don't know. Because you could have prevented it, right? It could be a thing that you might have fixed in your own code, but it could be a thing that you could have even reached out to the provider, maybe to their tech team. Oh, something is happening, right? So it's important that we monitor this resilience, monitor the uptimes of your providers, right? And honestly, in this case, providers can also be like internal APIs. Internal APIs, right? At Cora, we have different teams. And we see one team calling the API of the other team, right? In that kind of scenario, don't just assume that, oh, it's another team, is our company. We are going to know. You will not know. You won't know. You won't just know. Still treat them as if they are an external. Because to be honest, they are external. Honestly, because there are certain things. There's a limit to how much you can just go and miss that team and say, your API is down. What's going on? You'll be shocked. They have work that they are doing too, right? So you have to treat them and approach them as if they are external APIs. And then I think lastly, the next slide. Yes, it is a journey, right? It's not a destination. And the reason why I said the reason why I added this is that yes, some of these things like that I've added, right? I think even all of them, maybe not the circuit breaker. Sometimes I like the problem to happen before I implement that particular strategy. And there are times that it's good, right? Because I believe that over engineering is, and I used to do that when I thought that, okay, is when you are good, that you build a perfect system that does not break. So you now go and gather all the patterns. Okay, Google used this idea. InterSwitch used this one. Paystack used this one. You now want to build to-do list. You now say that, okay, it has to be a perfect to-do list app. You now gather Google's. Oh, God. And I'm saying this, trust me, it's from experience. I'm telling you it's from experience. I have built a very sophisticated blogging API before. Very, very sophisticated. The code was well structured. And I was so proud of myself. But nobody saw it. Nobody. I tell you. So it is a journey. Don't try to get everything done, right? Try to figure out what you need to do now and what you can do later. It's a journey, but now you have a map, right? And I think that's the end of mine. Yes, okay, this is just key points. Embrace failure as a feature. That's knowing that you cannot be the perfect system. Isolate, don't escalate. And by don't escalate, I don't mean that you should not now tell somebody that there's a problem. I mean in your implementation, right? That's what the circuit breaker does. Create redundancy with fallbacks, right? You have multiple integrations of the same feature. And then monitor the patterns, not just the servers. And then remember, resilience is a journey. Thank you. Any question? Let me be.
Thank you very much. Any questions?
I have questions.